The CC220 can connect multiple MS200s at once and is gathering the data of our sensors via Bluetooth and transfers the data then over to platforms and clouds via Ethernet connection.
Welcome to the Trend Detection Podcast, powered by Siemens. And now your host.
Hello and welcome to the Trend Detection Podcast. In this episode, we'll talk about the integration of SITRANS Multisensors into Senseye Predictive Maintenance. And my guest for today is Niklas. Hi, Niklas. Maybe you can introduce yourself a little bit.
Yeah, thank you very much, Johannes. Thanks for having me on the podcast. My name is Niklas Frey, and I'm responsible within the Measurement Intelligence unit of the IPA as business developer and consultant for the condition monitoring products within our SITRANS portfolio.
Thanks. That sounds good. So today we'll talk a little bit about an example on a concrete product to be integrated into Senseye or any predictive maintenance solution. So Niklas, can you tell us a little bit about what is the SITRANS MS200 multisensor and how does it fit into predictive maintenance?
So the SITRANS MS200 multisensor is a wireless battery-powered sensor that measures vibration, temperature, and magnetic field parameters. It can be retrofit on any kind of rotating or vibrating equipment in order to collect data from those assets. So far, there's a lot of assets where no information on the condition of those assets is available, and therefore we can provide valuable data containing all sorts of information on the device's statuses that can be derived by software tools like Senseye and many others.
All right, understand. So you said it can be mounted on any kind of rotating equipment. So I assume that would be mostly like pumps or motors, any other example?
Motors and pumps is probably the thing that most of us think directly when we're talking rotary equipment. But we're also talking fans, for example. We also can monitor the gearboxes of all those assets. And we're also talking, for example, mixers and stuff like that. So really any kind of asset where the vibration could give an indication of the statuses or the asset's status, health, and stuff like that.
Yeah. And I understand it's a solution to be retrofit. So basically an asset which is kind of dumb at the moment, right? So a motor which has not originally already a kind of evaluation on data. So and mostly we find this in brownfield, right?
Absolutely, definitely. I mean, of course, the solution could be implemented in greenfield as well, but the retrofitting aspect would perfectly fit into brownfield.
Yeah, understand. All right, and then we have the data collector, the multisensor, the MS200. How is the data then processed? Yeah, what's the way of the data to the predictive maintenance system?
So basically, we have the SITRANS CC220 acting as a gateway in between the sensor and the cloud platform, Senseye in this instance. So the SITRANS CC220 acts as a gateway device transferring the data collected from our multisensors through to any kind of platform. The CC220 can connect multiple MS200s at once and is gathering the data of our sensors via Bluetooth and transfers the data then over to platforms and clouds via Ethernet connection. With the gateway itself, of course, we handle all the device configuration of the sensor. We handle the setup of configuration towards which platform we want to deliver the data. And we could, in theory, of course, also use the CC220 as the entry point to introduce firmware updates on the sensor or to use things as log files for further analysis if there are any issues with the system in general.
All right. So basically, the multisensor is an unwired device, right? You can just plug it, mount it to the asset, and then we have the gateway to get those data from different multisensors. How many multisensors can be attached to one gateway? Is there a limit or?
Yes, there is a limit. For the moment, we are talking 12 sensors per gateway, which comes from the way we measure and how often we measure. So we have to think about measure cycles and how many devices we can basically gather data from. But we are also currently investigating at the moment in how many more sensors could we fit into one gateway. But of course, you need to evaluate if it makes sense. Since we're talking Bluetooth, we're talking about a limited range between sensor and gateway. And with that, it needs to make sense having as many sensors in that surrounding of the gateway. But we want to increase that number from 12 up to even more.
Yeah, I understand totally, because of course they have to be in Bluetooth range, right? And this is about probably 20, 30 meters.
Yeah, around 30 meters.
Yeah. So maybe if you have a big plant, of course, then you need multiple gateways for sure. But there's a new web server, right, for the CC220. What is it, and why it is such a big step forward?
So in the beginning of this whole project, we had a out-of-the-box solution combining sensor, gateway, and our own cloud application. This was more or less a closed system, and the customer would have basically needed to use all three of those components for the system to work. The gateway could only connect to our cloud backend and to our cloud application, and the configuration of the gateway and the sensor was basically directly done in our application. So overall, we were quite limited in how people and customers could use this application as a whole solution. And now with our new web browser or web server that we've implemented on the gateway itself, the configuration of the sensor and the gateway can be directly done on the gateway itself. And we have basically opened up the communication between gateway and the northbound component. So what that means is basically that SCMIQ is no longer necessary to use the sensor and to work with the data, but we can, with that web server, integrate everything directly into all kinds of systems via MQTT as a protocol. With that, we open us up on all kinds of different solutions, platforms, and we get away from that closed up, out of the box solution approach.
Yeah. Like, for example, integration into Senseye, right? But also probably third-party applications of a customer who already have kind of a predictive maintenance system. Okay.
Exactly.
Yeah, and how is the integration happening? Is there a protocol? What's the old cloud-based routing and what's the new integration?
So with the old routing of basically cloud to cloud or cloud to whatever, we were reliant on having our data in our cloud, in our application and the backend. And then we needed basically to reroute in our backend that data again to another entry point, like Senseye, for example. The big issue with that solution that we had as like kind of a pilot to try that out was that we would need to involve our team from the backend to basically manually set up that rerouting part. And of course, on the other side, so Senseye in this instance, we would have needed the Senseye colleagues as well to manually set up that rerouting on their side. So we had always both teams that needed to be available if we wanted to do such a rerouting. And of course, that's quite an effort and quite time consuming. to set that up for every customer who would be interested in such a solution. And now with the direct MQTT integration, the customer, for example, or an integrator or a partner who would use or who would set up the system at customers, they can directly set up that MQTT connection from the gateway to Senseye. So SCMIQ is cut completely out of the picture for this approach. And we would only need someone familiar with the web server of CC220 and Senseye as the counterpart to get that connection set up. And we don't need those both teams involved. We don't need them to work together in a very time-consuming effort to set up such a connection.
Yeah, that sounds much more simple now, for sure. Can you kind of walk us a little bit through such an onboarding process of a sensor using the CC220 web server now?
Yeah, absolutely. It's quite straightforward, actually. So after the SITRANS CC220 is connected to power, of course, you would need to set up a one-to-one connection via Ethernet to the CC220. So either with your laptop or some kind of working station, PC, whatsoever. You could then access the web server from your connected device and log in with your credentials. After that, you basically need to start with the gateway configuration, like the IP settings, name of the gateway. If you want to configure from an IT perspective, any kind of NTPs, DNS, like all those parameters, you would do that to configure the gateway itself. And then you would start directly in the web server, basically with the next page, with the configuration and the onboarding of the sensors. And for this, you would only need the MAC address of the sensor, because this is basically the unique identifier of our sensors. And then you would enter all the sensors you want to connect with their responsible MAC addresses. And then CC220 basically has them whitelisted. So the next time the MS200s are found within the Bluetooth scan of our CC220, the gateway knows which sensors to connect to and establishes the onboarding process between sensor and gateway to make sure that those two devices are allowed to talk to each other, to connect to each other. And then after that initial setup, the sensor knows which gateway to communicate to.
Nice, yeah. And how quickly can users then start seeing vibration data from the MS200 sensors in the Senseye dashboard, for example?
Basically immediately. So as soon as the connection from sensor through the gateway to Senseye is set up with the process I just explained, the data will be available in Senseye. So depending on the measurement cycles of our sensors that basically are configured through that web server as well, we make sure when data is being sent, and as soon as that initial configuration is saved and that initial connection stands between the sensor and the gateway, the first value will directly be sent to Senseye. And then the other values, of course, are depending on the measurement cycle the customer set.
All right. And will existing CC220 gateways get this functionality, or does the customer need new hardware, needs to set up lots of stuff and so on, or how it is like this?
No, the functionality will be available for all CC220 gateways, new ones as well as existing ones. The functionality will be provided through a firmware update. So the hardware of our SITRANS CC220 is basically already capable of doing that. And we just introduced those new features, the web server, the MQTT interface, with a firmware update. And this will be provided without any costs to all interested customers. And this can just be installed either on new gateways or on existing ones to upgrade the system.
All right. You already mentioned in the beginning, I guess, a little bit, coming back to the data the multisensor collects. So I guess there's, or you said, I think vibration data, temperature data, and also magnetic field data. But there are also KPIs, right, which the customer can see then in the application, which can be integrated. Can you say a little bit in this direction?
Yeah, absolutely. So on first instance, and for the moment, they can basically expect the raw vibration data. So acceleration over 3 axes. They can expect the temperature and the magnetic field data. From these data packages, or from these data sets, a couple of KPIs can be derived within Senseye directly. But we will also implement KPI calculation directly on the sensor itself. So with this, customers can freely decide what kind of data they want to use for an analysis, if they want the raw data and want to handle it themselves, or if they directly want to use KPIs for a more direct feeling on what's happening. And yeah, basically why we want to do that and why we want to have it configurable is that it's having positive effects on the quality of the analysis. And also we can improve the battery lifetime for the sensor because we don't need to send everything every time, but rather how a customer wants it to be. The KPIs that we want to introduce are the standard KPIs for vibration and magnetic field. So for the moment, we are talking RMS, we are talking peak to peak, kurtosis, skewness, and crest factor for the vibration. And for the magnetic field, we are currently thinking about the main stator frequency, slip frequency, rotational speed, and a kind of on and off detection for the asset itself via the magnetic field. We will also introduce a battery indication KPI, basically to supervise the battery status of the sensor to indicate if a sensor is running out of battery in the next couple of days, weeks, or months to prepare customers for that accordingly as well.
Yeah, that totally makes sense, right? So basically, the customer can have the raw data like vibration, temperature, and so on, but also the pre-calculated KPIs depending on how much is then processed on the application side, right? So lots of possibilities, and I think this in general helps the customer a lot to kind of see whether an item, needs maintenance, right? In the end, we're talking about predictive maintenance. So all this KPIs and the data then ultimately come into diagnostics for the specific asset and to see, okay, maybe now is the time the sensor makes an alarm, or in the application, it is an alarm that, maybe a device needs to be maintained and so on. So this, all the data makes it more than reliable, and of course,
Absolutely.
the prediction. So, and how does the new setup help customers scale? Like, for example, if they need to connect many sensors across a plant.
So there's kind of two approaches to that question. So in general, since we connect many sensors to one gateway, we already have quite a good method of connecting multiple different assets with just that one gateway. If we now have multiple assets across a whole plant, we talked about it, maybe one gateway then will not be sufficient, either because of the amount of the sensor or because of some limitations within distance and the environment. Then basically the very easy way to get that done is with that simple integration of CC220. So the CC220 integrates seamlessly within Senseye. It doesn't matter if I have one gateway or if I have multiple ones, they are quite easily integratable. And with that, I can get a lot of sensors into Senseye Predictive Maintenance. And the big benefit is that we could do that on the one hand, completely free from any kind of complex IT infrastructures. So we don't necessarily need to integrate the gateways into existing IT infrastructures if a customer would not want to do that. You can go directly from the CC220 via MQTT to Senseye to the cloud. That could be basically with some kind of mobile router or whatever, completely standalone from existing structures. But on the other hand, of course, we could integrate the gateway as well via MQTT in such existing infrastructures if that is more comfortable for a customer. For example, if a customer has maybe not only our multisensors, but also a lot of other data points and data sources, then maybe it might make sense to basically pre-sample all those data into one point, like a data collector, some kind of either IPC or database or whatever. And then we could integrate the CC220 into that via MQTT, of course, get the data into there first, and then all the data could go from one point up into a cloud. So either way, if we would want to use it more or less still standalone, or we want to integrate it in any kind of IT infrastructure, both of the ways are possible.
Mm-hmm. So very flexible, yeah.
Yeah.
So Niklas, yeah, looking ahead, what's on the roadmap basically for MS200, like for the multisensor and the gateway CC220, integration with Senseye? What are the plans? Yeah.
So the most important part for us for now will be the further development of our MS200 itself. So with the insights of Senseye colleagues and the pilot projects we're starting and the overall projects we want to do in the future, we want to learn what kind of data, what measurement cycles fit best for each application, and what might our sensor be still missing? What might we need to add in the future? Where do we see adaptation potential to further increase the quality and the benefit of our sensor as an integration part into Senseye, to basically make it the best fit, or at least a very good fit for all kinds of applications. In concrete steps, we are talking about making sure that the MS200's measurement cycles are configurable so that users can decide for their own what sampling frequency they want to use, how many samples, so the number of samples, the sensitivity, and how often they want to measure. Depending on the application, it might make sense to maybe take measurements every few minutes. For other examples, it might be once an hour. For others, it might be just a couple of times a day. And with that flexibility, we also ensure higher battery lifetime, of course, and we ensure really to get that data to customers and to Senseye that they really need, and not just fill them up with all kinds of data that is not necessary in that amount, basically. And directly afterwards, we will implement the KPI calculation on the sensor, which I talked about previously. And then maybe having a further look in a little bit of a longer future, we're of course also planning and investigating in changing our sensor from a measurement range perspective. So at the moment we are limited with up to of measuring up to 3.3 kilohertz, and we're just investigating into getting that number up and being able to measure also higher frequencies in the future.
Okay, so continuous improvements step by step, right, for the MS200 and the gateway. Great, Niklas. I think I don't have any more questions. Was really great talking to you to get an insight about the multisensor MS200 and the gateway integration into systems like Senseye Predictive Maintenance. Any last words from your side?
First of all, thank you very much for having me, for giving us this opportunity to present and to introduce the topic of SITRANS MS200 and CC220. as an integration part into Senseye. And other than that, I'm really looking forward to working together with the colleagues from Senseye to really making sure that everything works out from a technical perspective, but also that we have a really good strategic plan to work together in the future to make that as a solution and to hopefully see a lot of SITRANS MS200s in Senseye projects in the future.
Yeah, for sure. Thanks a lot, Niklas. So basically bringing predictive maintenance at Siemens to the next step, to the next level. And great having you here today, Niklas. Thanks a lot. And see you in the next episode of our Trend Detection podcast. Bye-bye.
Thank you. Bye-bye.
Please like and subscribe on all major podcast channels and find out more about Senseye Predictive Maintenance at Siemens.com.